All right. You factored way back in elementary school, and so we're going to talk about greatest common factor. We're going to kind of review the old way of factoring, like your elementary school factoring, to kind of help us review how we're going to do our high school algebra factoring. So if we look at factoring, there were a couple of ways that you did this in the past. There was prime factorization, where you made the little tree, and then there was the thing where you listed out, you made a list of factors, which is fine too. In algebra, we kind of do a combination of the two. Okay, so there was the prime factorization table where you made the little table and you said that 28 is 4 times 7 and 4 is 2 times 2, so you had 2, 2, and 7. We're not going to go that far. We're going to do a combination of that. We're going to treat the x's kind of different than we do the numbers. So I do what I call the rainbow, but I do it in a table. So the way I do it is I say 28. How can I get 28? Well, I can do 1 times 28. I can do 2 times 14. 3 times nothing gets me 28, but 4 times 7 gets me 28. There's no 5, no 6, and then I come back to 7. So these are all my factors of 28. So if I list out all my factors, I have 1, 2, 4, 7, 14, and 28. Yes, they need somebody from Club Rewind, but it's okay. All right, so these are my factors of 28. These are the numbers that I can multiply together in some combination. Each of these is a number I can multiply to get 28. Okay, that's what a factor is. Remember, factor is factor times factor equals product. Let's try 36. I want you to tell me what the factors of 36 are, like all of them. Just give me a list like this one. Okay, go. All right, so when I look at 36, I see 1 times 36. I see 2 times 18, 3 times 12, 4 times 9, 5 doesn't work, 6 times 6. And obviously I'm just going to go back the other way. So, well, yes, 9 times 4 is another combination. I've already got 4 and 9, so I don't need to list it again. So when I list out the factors I've got, I'll have 1, 2, 3, 4, 6. Now, I don't need to list 6 again because 6 is already a factor. If I list it twice, I don't need to list it twice. So I'm not going to list it again. And then I have 9, 12, 18, 36. Those are my factors of 36. Okay, so if I take those factors of 36 and I put them in a common factor table, all right? So you kind of already got your list of factors that you wrote up here. Let's write them down. So they both, if we circle what they have in common, they both have a 1, they both have a 2, they both have a 4, and I don't see anything else they have in common. So those common factors, 1, 2, 4, are going to go in the middle of my Venn diagram because that's where the overlap is. And then the other factors, so on this one, the first one is going to be 7, 14, 28. Those are only factors of 28. And then 3, 6, 9, 12, 18, 36 are only factors of 36. 1, 2, and 4 are the ones they have in common. Now, I've asked you what the greatest common factor was. What's the biggest number in there? So my GCF is 4. These are all factors, and these are all common factors, but the biggest common factor is 4. And so we're going to be looking for the biggest common factor. Now, that's how we do greatest common factor in elementary school. Now, let's talk about how we do greatest common factor in algebra. So we're going to add. What do we have that's extra in algebra? We have x's. Okay, so we're going to be thinking about what do I do with this? Okay, so if I look at the factors of x to the 5th, all I'm going to do is expand x to the 5th. So I have x times x times x times x times x. All right, that's what I've got. If I look at factors of x squared, I'm going to expand x squared. So I have x times x. So far, so good. All I'm doing is expanding. So I'm taking the base, and I'm expanding it by the power. Okay, remember, base to the power? Remember that? Okay. So how many x's do they have in common? Well, they both have 2 x's. So over here I have an x and an x. Now x to the 5th also has 3 extra x's. X squared doesn't have any more factors. So what do they have in common? Well, their greatest common factor is x times x, which is x squared. They have an x squared in common. So you can kind of see that we treat if you look at this, you can see that we treat the letters and the numbers differently. With the letters, we're looking for the biggest factor that they have in common, and with the numbers, we're looking for how many of that variable they have in common. Okay? Now, if I look at this and I see what the greatest common factor is, we already figured out that on this part, so if I look for the greatest common factor of 28x to the 5th and 36x squared, I'm going to find the greatest common factor of the numbers, 28 and 36, and the greatest common factor of the letters, x to the 5th and x squared. Well, the biggest number factor they have in common is 4. The biggest letter factor they have in common is x times x, which means the GCF is 4x squared. Okay? So again, what we're going to do is we kind of handle the numbers and letters a little differently, but we're going to find the greatest common factor of the numbers, the greatest common factor of the letters, and put them together. All right, so let's try that. Here's like an old school one, 12 and 36. I want you to find me the greatest common factor, and that's going to be just like this one here. I want you to find me the greatest common factor. You don't have to draw a Venn diagram if you don't want to, but find me the greatest common factor of 12 and 36. Okay, so if I look and I write my factors, I have one for 12. I have 1, 2, 3, 4, 6, and 12. For 36, I have 1, 2, 3, 4, 6, 9, 12. Oh my gosh. 18, 36. And I only know that because honestly, like, we totally just did 36. It's like right here. Okay, otherwise I don't think I pulled that out of my head. So I'm going to look for the biggest number they have in common, and it's right there, 12. So the GCF is 12. That's the greatest factor they have in common. All right. Now, I'm going to show you how to do this one. I'm going to do a couple of them with you, and I'm going to let you try one. I'm going to do this one. I'm going to let you try this one. Okay. So what we're going to do with this one is we're going to find the GCF of the numbers and the GCF of the letters, okay? So what's the invisible coefficient here? Well, it's a 1. So I'm going to start by looking at my number GCF, and then I'm going to look at my letter GCF, okay? So my number GCF, I have a 1 and a 2. Well, that's 1 and 2, right? Because the only factor 1 has is 1. The only factors 2 has are 1 in itself. So the GCF of my numbers is 1. Now I'm going to look at my letters. I have x squared and xy. So I'm just going to expand those. So I have x times x and x times y. Well, the thing they have in common, they both have one x. Now I can't say they have two x's because this one doesn't have a y, this one doesn't have another x. So all they have in common is one x. So my greatest common factor of the whole thing is 1 times x, which is 1x, or just plain old x. Okay? I'm going to do more examples. We're going to do a ton of examples of this tomorrow in class. So, like, if you're like, what? Don't freak out. Okay? I may not be able to let you do many examples because I want you to really see me working these out. Let's try this one because it's got 3 of them. I'm probably going to let y'all do number 4. Okay? Let's look at this one. I have 3 things I got to find the greatest common factor of. 2x, 4x squared y, 6xy squared. Now, what I can do, what do I know these all have in common? I'm hoping that what you're saying is they're all divisible by 2. Like, the biggest thing I can divide these all by is 2. So I have 2 times x. I have 2 times x times y. Here I have 2 times 3 times x times y times y. Okay, again, all I did was I can kind of already see that they have a 2 in common. Kind of like here, y'all probably already knew without doing any of this that the greatest common factor was 12. Okay, so I'm going to look at what number they have in common, or numbers. They all have a 2 in common, but they don't have any more numbers in common because this one only has 2. They all have an x in common, but they don't have anything else. So for this one, my GCF is 2x. Okay? So far, so good? Okay. So now, let's look at this one. This one's a little tricky. So I want you to try to expand it yourself. I'm just going to give you a minute to try to expand it yourself. And you're all going to say, well, what about the negative? negative, anytime you see a negative, it has a factor of -1. So take out the -1. And then I want you to try to find the greatest common factor. So I'm telling you right now, they both have a -1 as a factor. Go from there and see if you can find the rest of the greatest common factor. Okay, so if I look at this one, I have -13, oh my gosh, so much, x to the third, ab. I have -18x squared, a. So I said they all have -1 as a factor because they're both negative. This one, I can also multiply by 13. And then I can do x times x times x times a times b. Well, this should be just times. Sorry about that. This should be times. And then this one, for 18, I can do 2 times 3 times 3, because 2 times 9 is 18. 3 times 3 is 18, so 2 times 3 times 3 gives me 18. Then I have x times a. So now I'm going to start collecting things they have in common. They both have a -1, but they don't have any more numbers in common. They both have an x. They both have another x, but they don't both have another one after that. They both have an a, but they don't both have a b. So when I write that down, my GCF is -1 times x times a, which is -x squared a. And if you put -1x squared a, totally fine. It's not wrong. But we just don't usually put that one in there. Okay, so this is just finding the greatest common factor. The thing that we're going to do now is we're going to factor out the greatest common factor. So let me show you how we do that. So I think we already did this one. We already did x squared and 2xy, and we agreed that for this one, the GCF was x. Okay? So what we're going to do is we're going to expand each term and cancel out an x. So we're going to put both of these over our greatest common factor, x. And then we're going to rewrite it expanded. Okay, so we have x times x over x plus 2 times x times y over x. And then we're going to cancel out that x. So these cancel out, and these cancel out. What's left is x plus 2y. But when I originally this was one of my factors. So basically what I'm doing is, when they started this problem out, they distributed an x. We're undistributing that x. By dividing everything by x, we're undistributing that x. So x squared plus 2xy is equivalent to x times x plus 2y. How can we check that? We can stick that bad boy in a box. Okay? Oops, that's too much box. Okay. So I can do x times x plus 2y. X times x is x squared. 2y times x is 2xy. X squared plus 2xy. So basically you can see that all I did here was undistribute the greatest common factor. Okay? Let's try another one. Okay, so for this one, oh, we're not going to do this one, by the way. For this one, okay, so I have -4x minus 14. So I'm going to start by finding my GCF. Okay, so I have -4x and -14. Well, -4x is -1 times 2 times 2 times x. -14 is -1 times 2 times 7. Okay, all I'm doing is factoring it. I know that 4 is 2 times 2, but since it's negative, -1 is also a factor. So they both have a -1 in common. They both have a 2 in common, but nothing else. Okay, so my GCF is -2. Who can see? Can anybody see what the rest of it is? What's left? 2x plus 7. See, I have 2x and a 7 left behind. That's all that's left, therefore that's my other factor. Now, if I wrote it just like we did before, and I wrote it with the top over the bottom, it would be -4x over 2, -2, minus 14 over 2, over -2, right? -4 divided by 2 is 2x minus -14 over 2 is -7. 2x plus 7 is exactly what I got inside. Okay? Let's try this last one. And again, we're going to do more tomorrow. So if you're a little bit like, what? Just don't worry. We're going to do a little more tomorrow. Okay? So let's try this one. If I'm looking for the greatest common factor, I'm going to write it, expand it. So I have 25a squared plus 35a. When I look at my factors, that gives me times 5 times 5 times a times a. That's a 5, by the way, before y'all freak out. Okay? And then I have 1 times 5 times 7 times a. I circle all the things they have in common. Okay, so I have 1 times 5 times a, which is 5a. And then I have 5a plus 7 left. Okay? We're going to practice this a ton tomorrow. If you need to, look back over the video. I think I only had one question. I just want to make sure that you guys we're going to practice this a ton tomorrow. All right? I'll see you then.